today we are starting chapter 10, which is about ratios, rates, and probably tie some percent works into it today, or percent work into it also. It's February 25th, and the first lesson that we're going to look at is just a review of some important points about ratios and how to simplify them. First of all, if you remember correctly, the ratio is really just a comparison of like quantities measured in like units. It's very important that you get your quantities with the same units, or it's not a fair comparison. For example, if I was comparing 1 foot to 1 inch and I said that that was a ratio of 1 to 1, it wouldn't really be fair because 1 foot is much larger than 1 inch, so you'd have to convert them both to the same units. For example, 12 inches to 1 inch or 12 to 1 would be fair. Ratio AB can be written in two other ways. In addition to A to B with letters, we can write it as A colon B or A over B as in a fraction. Those are acceptable ways, three acceptable ways of expressing a ratio symbolically. Ratios, like fractions, always need to be in simplest form. And we cannot have fractions or decimals in a simplified ratio. So if you have a ratio with a fraction or decimal, you got to work with it a little bit to remove the fraction or decimal from it. Very important, order. The order in which a ratio expressed is important, and you can't just change it. You have to continue making the comparison in the same order that it's presented. So you must maintain the same order throughout a problem where you're working with a ratio. Those are some of the basics, and that sets us up to look at some examples for today. You copied on the directions in your notes. Example 1, we need to express this ratio in simplest form, 700 grams to 1 kilogram. Well, when you look at it, the first thing you should notice is that we don't have the same units, so we have to convert to the same units. It's easiest to convert 1 kilogram to 1,000 grams, so we end up with 700 grams to 1,000 grams. Now it's a fair comparison, and once you have gotten the same units, then you can drop the units. So once you get the same units, drop them. Ratios should not have units in them. So that means that this could be written as 700 to 1,000. We still, though, need to deal with the fact that it's not in simplest form because there's a common factor of 100 in both of these numbers. So I can divide the common factor of 100 out in the ratio in its simplest form is 7 to 10. Example 2 shows a decimal in a ratio, and we said we can't have that. So we want to clear the ratio of decimals, and the easiest way to do that is usually to multiply by a power of 10. If I multiply both parts of the ratio by the same number, I don't change the overall comparison. So to get rid of the decimal 3.6, I need to multiply it by 10, which means I also have to multiply the 9 by 10. So this is like a ratio of 36 to 90. So multiply by a power of 10 to clear decimals. We're still not done with this ratio, though, because there remains a common factor. Oftentimes kids will say, well, 9. So if I divide the common factor of 9 out of both of these numbers, I'm left with 4 to 10. Oh, it's still not in lowest form. I need to go a step further. There's a common factor of 2. So this ratio in lowest form, simplest form, is 2 to 5. Somebody could have back at this stage said there's a common factor of 18 and jumped all the way down at once. But if not, you can just go with steps, just like with a fraction. Example 3 illustrates the point that you can have a comparison of more than two quantities. Here we have three quantities in a ratio of 24 to 4 to 6. Is there a common factor among all three of those numbers or quantities? And there is. There's a common factor of 2 in all three. So I'm going to divide a 2 out, and I'm left with 12 to 2 to 3. Now kids often say, well, can I take a common factor out of 2 of them? And the answer is no. In order to simplify a ratio, the common factor has to be in all three of them. And there is no common factor in all three of these, so that's as simple as it gets. Okay. Let's look at a couple more examples before we wrap it up. And these examples have fractions. This is a new idea this year for us. Here we're comparing 2/3 to 5/8. And we can't have fractions in our ratio, so we have to figure out a way to get rid of the fraction part of this. Kids often suggest getting a common denominator, which is a great thing to do, because then it's easier to see how these numbers compare. Common denominator for both of these fractions is 24. So if I multiply the first one by 8/8 and the second one by 3/3, I end up with 16/24 to 15/24. At this point, it's basically saying 6 parts to 15 parts, because they're both in 24, so they're equal-sized pieces. So I can just say, well, that means that we have a ratio of 16 to 15. So get yourself a common denominator. And then the numerators become your ratio. I had a student earlier today say, well, I don't get that. Why can you do that, Mrs. Doble? And I, just as a little aside, said, well, let's look at one maybe a little bit easier and compare. We had the ratio of 3/4 to 1/4, right? And I drew a picture of it. I basically have, bear with my artistic abilities, that's 3/4 to 1/4. The fourths, you see they're equal-sized pieces, so you can see it's basically just a comparison of 3 parts to 1 part. So once you get that common denominator, you just look at the numerators to give you your comparison. Okay? All right, example 5 just kicks it up a notch. You should notice here that you have an improper fraction, or a mixed number. The way to handle it is to turn it into an improper fraction. So this is 4/3 to 5/6. Get yourself a common denominator. The lowest common denominator is 6. So this becomes 8/6 to 5/6. Basically 8 parts to 5 parts. So our ratio is 8 to 5 in simplest form. If you would have gone with a higher denominator than 6, that's fine. You just would have had to reduce more in this step. All right, these directions are a little different for our last 2 examples here. We have expressed the following ratio in lowest terms in the form of a fraction. Most kids just go to using the colons to express their fractions, or to express their ratios, but don't forget they can also be fraction form. So let's put these ones in fraction form. Example 6. When you look at it, you notice you have decimals, and you can't have that in a ratio, so you have to clear the decimals. Kids will often say, well, let's multiply both by 10, which is fine. You get 35 to 5, and you need to reduce it. Other times, kids will notice in this particular example, instead of multiplying both by 10, we could multiply both by 2. And when you do, you end up getting 7 to 1. So you get your simplest form ratio right away if you choose to multiply this particular example both by 2. Again, you could have done it by multiplying by 10. In that case, you would have gotten 35 to 5, which reduces to 7 to 1. So you can approach them from several different formats and still get the same answer. Okay? Last example, just to deal with some units here and thinking about it, we have the ratio of 2 minutes, 15 seconds to 2 hours. All right, well, we can do it 2 different ways. Probably the most common approach is change to seconds. 2 minutes. Each minute has 60 seconds. So this is 120 plus 15 is 135 seconds. 2 hours. Every hour has 60 seconds, or 60 minutes, and every minute has 60 seconds. So 1 hour has 60 times 60 seconds in it, which is 3,600. But we have 2 hours, so that's 7,200 seconds. Then you reduce. You got to reduce a lot. A factor of 5 takes us to 27. $14.40. Common factor of 9 in both of these. Takes us down to 3 to 160, and the reciprocal is 4. That's it for today.